Hey everybody, Mr. Stewart here, and welcome back. This is the third video in a three-part series capturing percentile, z-scores, and lastly, outliers. So intuitively, we know what outliers are, and we've discussed this briefly before. It's data that lie beyond what we might establish as a trend, or lie well beyond the scope of the data. And that scope is going to be defined by the work we've been doing recently. So work surrounding the middle or the average, the arithmetic mean of a data set, as well as our measure of consistency. So the standard deviation, okay, which is going to help us to measure dispersion or variability within data. Okay, so taking a look at the data we have, let's repurpose it from the last example, and this time I'm going to manipulate it a little bit. We're going to add in an extra datum. Okay, so for the purpose of example, I'm going to introduce a test score of 50, and we're going to make the test out of 50. So that 50 in relation to the other values is quite significantly different, okay, than the other scores. So at this point in time, I would venture to say that 50 could very well be an outlying value, okay, and that outlying value is going to change the mean. That is going to skew that mean, as well as change the degree of variation. So I would anticipate the standard deviation to already have gone up. Okay, so in order to assess that, you can take some time to sort of start visualizing the data to help you formulate a strong argument. So in Excel, you can see that I have included the original data set. So pasted that in, and here I've calculated the average, and here is the standard deviation for that data set. Over here, what I've done is I've included the 50 as the new value. So the 50, okay, so there's the average. The new average is 30.14, so it has gone up by about a percentage point. So that's relatively significant. That one datum in a small data set is going to influence that. And then you can also see that the measure of variation, or the standard deviation, has gone up to 7.85, which is roughly, what is that, 1.3 almost. So in terms of a raw score, so we're seeing 1.3 marks being added on here in terms of standard deviation. So that to me does represent particular value being an outlier. That is the 50. Also visually, what we can do is if you copy and paste that data from Excel into a spreadsheet, specifically this one here, Plotly. Plotly is an online calculator or graphing calculator, which will allow you to visualize some statistical plots. So using the box plot selection, let me show you the original set. So A represents the data in column A, which is the original data set. So hovering over top, we have all of the values that we would have identified as min, as max, and then as the quartile. So Q3, Q2 are the median, as well as first quartile, Q1. Okay, so there's a visual representation of that. Okay, so you can certainly tell quite a bit from this. I mean, by inspection very closely, the upper 25%, the lower 25%, and this particular 25% of the data, just assessing the width of those intervals, they're roughly equivalent. Okay, and then and this one here, 25% of the data there's a little bit less of it being pooled in between the median as well as the third quartile. Okay? So it gives you an idea of how the data are being dispersed in this distribution. If we then select plot B, so here's plot B, the scaling is the same, that is we have intervals of 5, okay, although the spread is much more, okay, because we now have a maximum of 50, okay. So significance of that? Well, visually speaking, right, if you start looking at how the data is chunked out, in these particular intervals, the lower 25% of the data just underneath the median value. Okay, here is another 25% of the data. And then we have quite a bit more spread here. So we have the upper 25% of the data between 34.5 and 50. So visually speaking, if you were to measure out the IQR, and you can see here I've copied and pasted that IQR. If I'm to stack that over top of the existing one and use the IQR as a measuring stick, you can see that by adding on one more IQR, okay, to the third quartile, to the 34.5, I now end up here just a little bit over what I believe is about 40, okay, or likely 42. If I were then to map slightly more of the IQR, okay, we're approaching roughly 1.5 IQRs above the third quartile. That 1.5 is a significant number. Okay, so in fact, in statistics, if a particular datum is 1.5 IQRs above the third quartile, or if a datum is 1.5 IQRs below the first quartile, we can qualify that datum as an outlier. Okay, so visually speaking, we can justify. Numerically is something that we're going to have to do as well. Okay, so let's take that particular score. So the score of 50, let's take that and let's relate that to how far above the third quartile that it happens to be. Okay, so what we'll do is we're going to take that 50. So we're going to find out the difference between the max and the third quartile. And the maximum value now at 50. The third quartile, now we can go ahead and we can start dividing up our list of data as we had done before. What you're going to find though is when using technology, the tech is more than likely using some form of algorithm or formula. There is a way to calculate or to position your quartiles and percentiles using a formula. Okay, we can use those formulas. They are tedious to use as well as to write. So I would recommend for a small data set that you sort of go through and use your understanding of the concept and dividing the list up yourself or manually to find them. If the data set is large, I would then definitely recommend that you input them into some app or into a website calculator and go from there. The website calculator will give you a value that is close to what you would calculate manually, but may be slightly different because of the nature of the formula. Okay, but being that we're using tech, we're going to utilize these quartile values. So 34.5 is our third quartile. So I'm going to utilize that in my calculation. That gives us a difference of 15.5. Okay, so to conclude, that means that 50 is 15.5 marks above third quartile, and marks representing those raw scores. So in order to make it relative to other data, okay, the absolute value is helpful, but if we're going to relate that back and make it relatable to other distributions, especially when data has changed, what we want to do is make comparison. Okay, so we need a relative frequency, which is why I'm suggesting a ratio. So under part 2, if you do hear a lot of scratching or pen tapping in the background, that's the stylus on the screen. So it's an unfortunate byproduct of using a stylus in this form of tablet. So let's get a ratio. So we are now going to compare the difference we've calculated to the IQR. So the difference we have is 15.5. The IQR will take the third quartile, and according to the Plotly plot, let me go back. we have 23.75 as that value. So let's get back in here. We'll subtract 23.75. So I'm going to calculate the quotient. So we'll take 15.5. We'll divide that by the difference of 34.5 and 23.75. Okay, so there's the value of the denominator. Pressing equals, it's about 1.44. Okay, so what that means for us, let me rewrite this here just to try to clarify. So the difference of max minus Q3 divided by the IQR is giving us about 1.44. If we're to rearrange that, okay, what we can see is that the max minus Q3, right, if we isolate max minus Q3, we would multiply 1.44 by the IQR. Now that's significant. That's a significant finding. Okay, and here's why. As mentioned earlier, statisticians are telling us that an outlying value will be 1.5 times the IQR away from either of those quartiles. So what we can see for us, right away, is that the 1.44 IQRs, that falls underneath, right? It's less than the 1.5 IQR ruling that's been given to us, which means or implies that the score of 50, or x equals 50, is not, okay, not, that's important, an outlier. So what we may have believed, what I had believed to begin with as being an outlying value, because of the changes in the standard deviation and its mean, as well as intuitively just looking at a value of 50 and being more than what we have already, one would think that it is an outlying value. But here, it's distance above, right? So that's what this is here, really. So its distance beyond the IQR, right, is 1.44 IQRs, less than 1.5 of them. So that's one way that you can determine if it's an outlying value. So you can figure out, just to recap here, figure out that distance. So figure out the deviation. How far above the quartile is that new value or below it? Make a ratio from it, right? So compare that deviation to the IQR and assess the size of the IQR. If it is less than 1.5, you've got yourself a value that is not an outlier. If it's greater than, then you're looking at an outlying value. Okay. Another way to do it numerically is to set up as such. So if you were to calculate, okay, so if we took 1.5 IQRs, so if we took Q3 and we added 1.5 IQRs to it, so Q3, according to Plotly or to the graph, was 34.5. If we add on 1.5 multiplied by, now the IQR we calculated as this here, that was 10.75. Okay, so let's calculate that here. Okay, so there's 1.5 IQRs already rated 16.125. That's 16.125 is well above the 15.5. Okay, we could conclude on the basis of that, but let's continue the calculation. So I'm producing or getting a value of 50.625, which is greater than 50, right? It's greater than the max. And because it's greater than the maximum value, right, we know the max lies underneath or lies below the 1.5 IQR ruling, and we can conclude that it's not an outlier.